Some people are scared of pointers. There's really no need to be. Being scared of memory management, maybe, but not of pointers. Pointers and references are just another way to talk to the variables that you already have in your code. And if you want to use certain constructs within your code, passing by reference, passing by address, keeping a pointer to something in something else, you gotta learn to work the syntax. Where does the star go? When do you use the arrow? What does the ampersand mean? In order to work with pointers and references. But it's quite doable. Same with const. Const keeps your programs correct. It keeps you from accidentally changing things when you didn't mean to. You have some function called getName. It shouldn't change somebody's number, and the compiler will help you through that. It's especially important if you're writing any kind of a function that takes a parameter by reference but that might be given a literal like 3. And it tends to spread through your code. Once you decide that this operator takes a const reference, then you discover that, oh, gee, that means getNumber has to be const, and getName has to be const, and this other thing has to be const. It's a much better habit to build const correctness in right from the very beginning. The minute you find yourself taking a reference, say, why am I doing that? Am I doing that because I want to change it? Or am I just doing it for speed so that I can avoid the copy? If it's just for speed, immediately say const whatever reference. Even if it doesn't matter to the compiler, it matters to other humans who read your code. Now they know why you're taking it by reference. It's just for speed. And there are a number of member functions that you can write in objects that have a standard canonical form. The copy constructor has to take a const reference to whatever this type is. The assignment operator, the same. The addition and arithmetic and comparison operators have a standard form that involves typically taking a const something reference and often returning references as well. So you need to understand references and you need to understand const in order to do a good job of writing operator overloads so that someone else doesn't come on and look at your operator overload and go, what? What? That's not what you return from that. Make it right. A real program, a program that doesn't just count to 10 or print someone's name out over and over again, are the kinds of demos we've been writing. Real programs involve long-lived objects. When the program starts running, somebody creates an object and many other parts of the application interact with that object throughout a long and healthy life. And that long and healthy life is almost certainly spent on the free store, which some developers call the heap. In order to allocate memory on the free store, you have to call new. That gives you a pointer, and then you have to live with pointers. You can't live a pointer-free life because you're going to need to get stuff living on the free store. That means you're going to have to be comfortable working with pointers. The thing is, it's not a done deal that means you have to do memory management by hand. If you knew something, you must either then take responsibility of following it around for the rest of its life to see if you should delete it, or, the smart thing, immediately put it in a shared pointer or a unique pointer, a smart pointer from the standard library. When you immediately put it in a smart pointer, you never have to delete it. The scope and the lifetime of that smart pointer, which is just a local object, an object on the stack, will control the lifetime of your free store memory and the destructor and all of the things associated with cleaning up. That's the smart thing to do. Smart developers use smart pointers. Manual memory management is hard. Smart pointers make your life simpler. I've shown you the hard way because I think you should know, not because I think you should run out and write the big 3 in all your classes for the rest of time. The smart thing to do is not to have to do that.